device started crying, whatever it's doing. So it said, turn me on. Okay, good, it's on now. Okay, I would like us to determine the slope of the tangent line at P. What do you think we're going to write? Tangent line at P. Now, we know how to determine the slope of the secant line. And all this time, we talked in the last 2 sessions at least, or 3, we talked about a very important operator. So do a combination of this and tell me, how do I determine the slope of the tangent line at P? For sure, exact. What will you say? I'm sure you're going to say the limit as x approaches a from f of x minus f of a divided by x minus a. We are putting together 2 concepts, the concept of average rate of change and the concept of limit. So, rate of change, of course, of a function between 2 points, etc., etc., and limit. And the result is slope of a tangent at the graph of a function at P. So the average rate, and with a limit in front, these put together will give us the slope of the tangent line at P. Now this also has a name, and it's a value. In other words, a number. And it's f prime of a. So let's write what f prime of a represents. F prime of a is the instantaneous rate of change of function f of x at P. Also, the slope of the tangent line at P. Also, the derivative evaluated, the derivative of f of x, of course, evaluated at x equals a. All these mean the same thing. The instantaneous rate of change, the slope of the tangent line at P, and the derivative evaluated, the derivative of f of x evaluated at x equals a. They all mean the same thing. Now, a question before we move on to another definition. So this is one definition that we are looking at today. So I'm going to call it definition. I'm not going to give any numbers. So definition. F prime of a is limit as x approaches a from f of x minus f of a over x minus a. This is our first definition. Let's suppose f of x is measured in miles. Let's also suppose that x is measured in hours. What is the measurement unit for f prime of a? What would be the measurement unit for f prime of a?
Miles per hour.
Thank you very much. So remember, this is the rate of change. The derivative will always have the measurement unit for the derivative will always have 2 measurement units. A measurement unit for the top of the ratio, top of the ratio, and the measurement unit for the denominator of the ratio. So if you determine the measurement unit for a derivative and you say kilometers, that can be right. You can say atmosphere per inch. You can say cubic feet per hour. You can say anything, but it has to have two measurement units. Temperature per minute. Just anything you can think of. Dollars per unit. But the measurement unit for a derivative, it has to be the measurement unit for a rate of change, which has two measurement units. Okay, back to our same graph, because we have another definition for the same thing. Why? In some situations, for certain functions, one is easier to handle than the other. They mean the same thing. You've seen both already. Maybe this is not the best color. Okay, so here it is. Of course P, of course Q, but this time this is A, and this is A plus a little bit. And now, can anyone give us the y coordinates for these points? Because, of course, we are after the same thing. We want to determine... Say it again.
F of A and F of A plus E.
Thank you very much. Great job. And we want to determine the same thing. So we want to determine f prime of A, which is the slope of the tangent. I don't know why I'm writing tap instead of tangent at P. Okay, so this is definitely limit as h approaches 0 from f of x plus h minus f of A plus h minus f of A divided by h. This is the other definition for the same thing, for the rate of change of the function at a point. And it says that my battery is running low. Forgive me 1 second, I have to plug it in. Where is it? Okay, got it. Okay, it's plugged in. Okay, so this is another definition for the derivative of a function at a particular point. So this is not a function. This answer is a value, a number. The slope of the tangent or the instantaneous velocity if the function represents the distance formula or function. So this is how we determine the rate of change directly. Before we move on to what is called the function, the derivative function, I would like to look at some examples. Okay, so where is my 2.7? My 2.7 is right here. Given a function, please choose. So quadratic, quadratic, rational, radical. You choose. We're asked to find the equation of the tangent line to the curve at the given point. And you can choose any type of function you'd like.
Can we do 6?
You want to do 6?
Yeah. Okay,
the quadratic. This is cubic, actually. Okay. Very good. So let's say problem 6. We have y equals x squared minus 2x cubed, and the point is given to us 1 comma negative 1. Obviously, when I look at this, I plug in 1, I know it's negative 1. That's correct. So they are really asking us to determine y minus y1 equals the slope times x minus x1, where the point is x1 comma y1, so 1, negative 1. So the only thing I need to determine is m, which is the slope of the tangent line to the graph of y. Perfect. So in order to find f prime of 1, that's what this is, this will equal f prime of 1. The derivative evaluated at 1. So in order to determine that, I have to write the definition. And I have two options. Either I write when x approaches h, when x approaches 1, or the other option is when h approaches 0. So I'm debating with myself. I don't have a recipe per se for a particular function, but sometimes this definition is easier than this. So we either use h approaches 0 or x approaches 1, but we have to make a decision. Which one would you like to try? When x approaches 1 or when
h approaches 0?
Fine. So limit as h approaches 0 from f of a, which is 1 for our case, 1 plus h, minus f of 1 divided by h. Okay, so f of 1 is no problem. I have it. It's negative 1. I know that. It's already given to us in the problem. This is negative 1. H is h. I cannot do anything to it. Let's take this on the side, simplify it, and then put it back in. Okay, so f of 1 plus h is 1 plus h, everything squared, minus 2 in parentheses, 1 plus h cubed. Now, we have several options to expand this, and then expand this, and then try to simplify, combine like terms, whatever. What I recommend, however, is factor out. It will be easier to multiply, I think. So these two have in common 1 plus h squared. Let's see what is left. From here, I have just 1. From here, I have negative 2. From 3, I took in front 2 of those, so there is a 1 plus h left inside. Now I can expand this, and I didn't keep the first page, but I kept it for another class, so I can always go back to it. How many terms do we get? How many terms do we get when we square a binomial?
3.
Absolutely, please be careful, 3 terms. I kept it for my college algebra class. So this is 1 plus 2h plus h squared. This is this piece. And here I have 1 minus 2 minus h. 1 minus 2 is negative 1 minus h. And this is much better now. It's easier to distribute than raise 1 plus h to the 3rd power, which will have 4 terms. And then this, and then simplify. So now I can distribute negative 1 to all these 3 terms and negative h to all these 3 terms. And let's see what we get. Let me stop. I want you to stop if you have questions. Anyone? I'm sorry, I don't want to just run. Any questions so far? Can you follow, everyone?
So far, so good.
Yes, everyone? Okay, very good.
Yep.
So negative 1 distributed here is negative 1 minus 2h minus h squared. Negative h distributed to these 3 is negative h minus 2h squared and minus h cubed. I can combine like terms, these two and these two. I'm going to rearrange it correctly in the correct order, meaning this. And then minus 3h squared, and then minus 3h, and of course minus 1. In the next step, I have to put everything together. So now f prime of 1 will be limit. Do not drop the limit operator till the very last step. F of 1 plus h is negative h cubed minus 3h squared minus 3h minus 1. And then minus negative 1, so this will be positive 1, divided by h. As we know from 3 weeks ago, all terms without h must go away. And they do. In the next step, of course I'm going to ask you to plug it in, and you know it's 0 over 0. It's one of the indeterminate cases, and there is hope for it. So then limit as age approaches 0. Pull out an age. I would like to pull out a negative age. That's how the second thing happens, which means h from the denominator must go away. There are 3 terms left at the top, so positive h squared, and positive 3h, and positive 3. So the answer is, can anyone give us the answer?
3. Sorry, negative.
Excellent. We go back. We plug in here negative 3. So then y plus 1 equals negative 3x minus 1. And we get negative 3x, and we get positive 3, and we move negative 1 to the other side. So y equals negative 3x and plus 2. This is the equation of the tangent line to the graph of x squared minus 2x cubed at the point 1 comma negative 1.
What did you plug 3 back into? Like, where'd you get the y plus 1? Okay, we went back to the top? Okay.
We are asked to find the equation of the line. Thank you. Any questions on this? And I just realized I wasn't trying to see whether you were asleep or not. So 1 negative 2 is correct. But negative 2 times h, I swallowed the 2. My apologies. So because I swallowed the 2, I have to go back and correct myself. So the first 3 terms are okay, but negative 2h, negative 4h squared, and minus 2h cubed. I should have written it and not... Okay, sorry about that. I'll tell you later how I realized that something was wrong when I looked at the function. I didn't look at this function before, you just picked it. So, but I realized that something went wrong because we're going to learn very soon in chapter 3 at the very beginning how to differentiate this. And this is 2x minus 6x squared. And when I plug in 1, I don't get 3. That's how I was checking myself, and I said, oops, there must be something I did. So negative 2x cubed, indeed, that's correct. Now negative 5h squared, and negative 4x, and minus 1. Sorry about that. 5 and 4, minus 1 plus 1, that's correct. So here there is a 2, here there is a 5, and here there is a 4. So that's how we get negative 4, correct? Okay, so then that's negative 4.
Never mind.
Because it's 2x minus 6. 6 minus 2 is 4. Negative 4. Okay, so negative 4, positive 4, and plus minus 1. So this is minus 4x and plus 3. So the error was here. I should have written this out like 1 minus 2x minus 2 minus 2h, and that would have not happened. So 1 minus 2x and minus 2h. So that's how we get negative 1, but minus 2h, not minus h, which made no sense. So then when I distribute it, now I have to check one more time. I know it's correct now, but I just want to check. So that's correct. And then minus 2 and minus 4 and minus 2h cubed, yes. And then we had, this is alone. These two are minus 5. These two are minus 4 and plus 1, minus 1. Okay. We copied that. Minus 1 and plus 1, that's correct. Goes away. H in front, negative h in front. 2h squared, yes, plus 5h and plus 4, correct. These two go to 0. So this is indeed negative 4. We plugged it in. Negative 4x plus 4 and minus 1, and that's correct. So what does this represent? The equation of the tangent line at 1 comma negative 1, tangent line to the graph of f of x at 1 comma negative 1. Very good pick. Okay, I would like to look at problem 15. If you have WebAssign pulled up, if you have the book pulled up, I'd like to discuss this function and the problem. I'm going to graph it here for everyone anyway. So a particle starts by moving to the right along a horizontal line, the graph of its position function. So this is problem 15. Here's the graph of the position function. 1, 2, 3, 4, 5, 6. This is t. And 1, 2, 3, 4. And this is s in meters. And this is t in seconds. Okay. So the graph starts at the origin and goes to 1, 3. And then continues to 2, 3, and then comes down to 3, 1, 4, 1, and 6, 2. 6, 3, sorry. Yeah. So here's the graph of the function. So this is the graph of the position function, position. And we're asked to write exactly underneath, to graph time still in seconds, but the velocity. Can anyone give us the measurement of the velocity? I'm going to copy the exact same values, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. A particle starts by moving to the right along a horizontal line. The graph of its position function is shown in the figure. When is the particle moving to the right, moving to the left, standing still? That's our first question, part A. When is it moving to the right? When is it moving to the left? And when is it standing still? So 1, 2, 3, 4, 5. So let's decompose it piece by piece.